Lesson 15.2, Task 1. Classify polynomials. A polynomial is a monomial or a sum of monomials. You can classify a polynomial by the number of its terms. A monomial has one term. A binomial has two terms. And a trinomial has three terms. An example of a binomial is 2x plus 4. An example of a trinomial is 4x squared plus 3x plus 2. So those are definitely definitions that you need to know. You need to know the difference of a monomial, a binomial, and a trinomial. And those are just all special terms for polynomials. Those are all still polynomials. They're just special terms for a polynomial. Connect to vocabulary. You can use the prefixes by and tri to help you remember the number of terms in a binomial and trinomial. The prefix bi means 2, as in bicycle, and the prefix tri means 3, as in tricycle. All right, you can also classify a polynomial by its degree. The degree of a polynomial is the degree of the term of the polynomial with the greatest degree. To find the degree of a term, calculate the sum of the exponents of the variables in the term. All right, so the degree is the term with the highest exponent. So for the first one here, this one has no exponent, and this one has an exponent of 2. So the term with the greatest degree is negative 2x squared, and your degree comes from the exponent, or the sum of exponents. So this one is 2. Here, this one has a 2 and a 4, so that one's 6. This one has a 5, and this one doesn't have one at all. So the first term, x squared plus y to the 4th, is the term with the highest degree, meaning you add the exponents together to get the largest number. 2 plus 4 is 6. Here we've got 3 and 4, which is 7, and here we've got 7 and 1, which is 8. 8 is greater than 7, so that means negative 18, x to the 7th y, is the term with the greatest degree. And the degree would be 8, because 7 plus 1 is 8, and you add the exponents together. All right, a polynomial in one variable is written in standard form when the terms are in order from greatest to least. The coefficient of the first term of a polynomial written in standard form is the leading coefficient. All right, so standard form, you write it in order from greatest to least degree. So we're talking about exponents. And the coefficient of the first term of the polynomial is written in standard form, and that is your leading coefficient. All right, so here we've got a 1, a 3, no exponent, and a 2. So that means the 2x cubed comes first, and then we go to the x squared, the x, and the negative 8. So you have to rearrange these to put it in standard form. Now if you look, 3, 2, 1, no exponents. So we're not looking at the coefficients, we're only looking at the exponents when we put it in standard form. The leading coefficient, again, comes from your first term, and it would have the highest degree. So 2 is your leading coefficient. All right, so for this one, we've got 6, 3, 1, and no exponent. So we put it in order, 6, 3, 1, and no exponent. So this is in standard form because our degrees go in descending order. And our leading coefficient is negative 7. All right, so those are just some examples of how to put something in standard form. All right, so the expression 7x cubed plus 4x to the 5th minus 2 blank a polynomial. All right, this is a polynomial because all of the terms are monomials. So you got 1, 2, 3 monomials. Together that makes a trinomial. The expression x squared minus 8x to the negative 3 plus 1, because you have this negative exponent, this one is not a polynomial, because not all the terms are monomials. All right, complete each statement about the terms. All right, so we've got 3, 1, 6. All right, so it wants to know the degree of each term. So the degree of this is 3, because that's your exponent. The degree of this one is 1, because x to the first power, it doesn't have to show the 1. You just assume that 1 to be there. This one is a 6, and this one doesn't have a variable, so there's no exponent. So it would be 0. All right, complete the statement. The degree of negative 4x cubed plus 5x6 plus x to the 6 minus 20 is, so the degree comes from your highest exponent, so it would be a 6. All right, do you think the polynomial here is written in standard form? All right, so let's check. 4, 5, 6. So if we count the degree in each monomial, we can see that it is not in standard form because it should go from highest to lowest. So it should be y to the 6th plus 2x squared y cubed plus 6x to the 4th. All right, choose the correct words to complete the statements. The coefficient of the term with the greatest degree and the leading coefficient of the polynomial here are, all right, so we got 2, 7, 3, no exponent, and a 1. So 5x to the 7th. The coefficient of the term with the greatest degree is 7, and the leading coefficient would be 5, so that's the same. This is true for all polynomials. All right, so the highest degree, the leading coefficient will always be with the term that has the highest degree. So when you put that in standard form, that would be your leading coefficient, but until you put it in standard form, it still is the term with the greatest degree. All right, give an example of a polynomial that has 3 terms, a leading coefficient of 7, and a degree of 5. All right, so if I want to do that, see, I'm going to have 3 terms. I'm going to have 1, 2, 3 terms. I have a leading coefficient of 7, and a degree of 5. So we got 7x to the 5th plus 3x squared minus 2. All right, and this is open-ended, so this could have a lot of different answers as long as you have the 7 and the 5, and you have 3 terms. Anything in that would work as a correct answer. All right, that is all for task 1. If you have any questions, let me know. Lesson 15.2, task 2. Analyze visual models for polynomial multiplication. You have used algebra tiles to find a product of monomials. You can also use algebra tiles to find a product of polynomials. The algebra tile diagram shows the product of a monomial and a binomial. All right, so you can see here that we have 2 x's, and they're both positive. Here we have an x that's positive, and then we have 4 negatives, and these are individual numbers. So these represent x's, these represent numbers, and then remember an x times an x represents an x squared, which is shown as a square. All right, so it looks like we have 2 positive x's, and we have an x minus 4. So it says, which of the following is the product shown by the algebra tile diagram? So again, here, these represent x's, so this is 2 x's, and this is x minus 4. So 2x minus 4 is what's represented. Explain how you identify each factor. Again, we just looked to see if it was positive or negative, and we just know the difference between an x squared, which is a square, an x, which is a rectangle, and then the small ones are individual numbers. And the positive and the negative, that's self-explanatory. If it's positive, it's got a plus. If it's negative, it has a minus. All right, so explain how you can use algebra tiles to represent the product as a polynomial. All right, so if we look at the algebra tiles, we can say x times x is x squared, x times x is x squared, and you can see that x times negative 1 here is negative x, and so on. So this represents 2x squared, and then it looks like negative 8x. So that's how you could use the picture there to see that. So it says the product is 2x squared minus 8x. All right, match the operation or property used in each step to find the product shown by the algebra tile diagram. All right, so we got 2x times x, and then we have 2x times negative 4. So we're using distributive property to start with. So we have to multiply the first term by each term inside the second parentheses there. So we've got 2x times x, and then 2x times negative 4. Okay, this is called distributive property. All right, and then we have multiplication here. So this is just going to be multiplication in the next step. And then anytime you have plus a negative, that's the same thing as subtraction. So these two statements here are equivalent. They are both correct. If you wrote it either way, it would be correct. This is just the most simplified form. Once you get to plus a negative, it helps to write it like this, as you want to always have it in the simplest form. All right, that's all for task 2. If you have any questions, let me know.